Yeah, welcome to hi folks. Welcome to another episode of Azure Microsoft Azure Community User Group. I'm Kevin, Nicholas.
Hey folks,
Hi,
welcome aboard.
welcome. This evening we have another theme called is Azure Virtual Network Manager and Agentic DevOps. So before we get started, let's start with the intro.
There's AJ. Hey AJ.
Hello.
Okay, Santosh might be just taking a break. Okay, first up anyway, AJ, apologies about those technical issues at the start. Lovely to meet you. Folks, this is AJ Bajada. Did I get that right, AJ?
Hey, good. Spot on.
Awesome. Okay. Who's a managing consultant at Arinco, and AJ's session is going to be titled How I Used Agentic DevOps to Deliver a Major Enhancement. For anybody over here in Europe, the UK, Ireland watching this, and it's like 7:30 p.m. AJ, let the folks know what time it is in Australia at the moment.
It's 6:30 a.m. in where I am, bright and early.
That is dedication. So if you see AJ supping on multiple coffees at this hour of the morning, no, we really, I said this to you earlier, I really appreciate you coming on the stream so early. For you guys, really looking forward to the session. And as usual, I suppose the question I always ask our speakers is, if there's questions from the audience coming in, do you want us to drop those questions during the session, or do you want to hold them till after? It's totally up to you.
I'm happy during the session, after, whatever everyone feels comfortable with. I'm okay with.
Okay, cool. So what we'll do is we'll flash them up, and then you can address them when you have a moment, okay?
Yeah, perfect.
Okay, perfect. Do you want to share your screen? Just because I know Nick is having some technical issues, so just want to see if you can share your screen there, and let's see if we can get you up and running. Yeah, that looks good.
Come through? Yeah, cool.
I can see that.
All right, great.
Right. Well, I'll hand the floor over to you, AJ, and as I said, we'll drop some of the questions as they come in up on screen, and you can answer them in your own time.
Yep, perfect. Thank you.
Excellent. Over to you.
All right, thanks. So yeah, today's session is all about how I delivered a major enhancement using Agentic DevOps. Now, before I get started, to go a bit intro to myself. Kevin already did a little bit, so thank you, Kevin. But yeah, AJ Bajada, I'm a big enthusiast around Azure DevOps, AI, automation, all those sorts of things. And as you can probably tell from what I'm wearing and my background, I'm a big Star Wars fan as well. So if you have questions about anything in any of those areas, feel free I've got some QR codes on the screen, so feel free to scan those, send through any questions if you're not comfortable in an open forum or in chat. More than happy for you to send them through. That just goes straight to my LinkedIn, so feel free to message me. The demo, any demos, anything I'm demonstrating today will be available on my GitHub account, so that will take you straight to my GitHub handle, and so you'll be able to go straight to any demos I have as well. So those just are up there, so feel free to scan those and I'll take a picture of those. I'll take you directly there. But that's today's not all about slides. It's all going to be 100% interactive, and I'm going to kind of go through my process on how I delivered my major enhancement. So I might just switch screens a little bit to my browser. So just bear with me. Cool, I've got Inception going. Does that come through okay? Can everyone see him?
Oh. Yeah.
Yeah, we can see. Just
Thank you, sorry.
be conscious of the Zoom when you're showing code, AJ. It can be a little bit tight on StreamYard.
Yeah, no worries. I might just set the scene a little bit. You don't have to really. This is just my Azure portal. So kind of set the scene a little bit. I'm working day to day. I have lots of meetings, juggling lots of things. And one of the challenges I ran into was I needed to work and to deliver a major enhancement to something internally I was working on. But capacity was a challenge. And then when I found dedicated time to do so, I found it took me a while to get back into the rhythm and focus. And then by the time I got into the rhythm, I had to then context switch to something else. So it was a lot of context switching, and it wasn't really a productive use of my time. So I had to think, I'm like, we have a lot of AI tools out there. There had to be a better way to do this. So what I want to show on the screen is more of a simulated, I guess, a version of what I delivered. So what I delivered a major enhancement on was something internally, so I can't, show that because of internal IP. So I've just simulated a web app here, and we're going to go through that same process I used, the exact same process to deliver a major enhancement here today. So I have here on my screen, in my own Azure portal, a web application. I'm going to bring it up. So at the moment, it's just a standard static web app. Now, like I mentioned earlier, I'm a big Star Wars fan. So this is a static web app where you can log in.
Sorry, AJ, can you zoom in a little bit? Because it's,
yeah, sure can.
Some people couldn't read it just because it's black. Thanks.
Yeah, so this is just a web application that I spun up. I actually just used the GitHub Spark to create this. So if you haven't used GitHub Spark before, it's really good. You can spin up front ends really quickly, just using natural language. So yeah, definitely encourage you to have a play around with that. So yeah, I just created a web app here where I can log in. I'm going to log in as Darth Vader here. And the idea is I can come and buy some ships because that's what I want to do, get some more details on ships, etc., etc. Add into my cart, saying, yes, that looks good. I'm going to buy all these ships, so I have lots of money. And because I'm Darth Vader, everything's going to get approved. It's all very good. So you can see all that's working in my static web app, which is all really, really well. Now, a big flaw in my system is I don't have any monitoring on my web app. So we're going to use this to kind of simulate, well, how can I use Agentic DevOps to deliver, this is a production or it's going to go to production, but I need some monitoring for my web app in Azure. So how do I deliver, I guess, just major enhancement to this using Agentic DevOps? So that's what we're going to simulate today. So you'll see that if I go to this resource group, there will be, I'll zoom in because it's a bit hard to see, but you can see here I have some things that have been spun up because I've already spun up using Agentic DevOps. So I'm going to show you the process and how I delivered, got these monitoring components in App Insights, Action Groups, and Log Analytics Workspace to my web app using Agentic DevOps. So that's what I'm going to go through today. Okay, so what I'll do is I'll switch to my code editor where I have this repository for this code, and I'll go through the process I was running. So just bear with me while I flick over to my code editor. Oh, there it is, just popped in. Okay, so hopefully everyone can see that okay. If you can't, just let me know and I'll zoom in a bit more. So this is my code repository for that exact application that you saw before. So all this does is just deploys that to Azure as a static web app. So I want to kind of simulate here So like I said, we set the problem that we need to deliver some monitoring to this repository, to this production application. So I needed to get started somewhere. So what I needed to do was to come up with a plan. So how do I use AI and Agentic DevOps to come up with a plan? I knew AI tools existed, and I didn't want to create my own plan from scratch because that's too time consuming. And yeah, I didn't want to go through that process because I didn't have the capacity to do so. And we have all these tools available, so let's use these tools. So I'm like, all right, perfect. Let's go through and use AI to help us create a plan. So I was thinking in like different ways to do so. And I'm not sure if anyone's across Awesome Copilot. So Awesome Copilot is a repository where it has a bunch of different, a collection of different things that you can leverage for GitHub Copilot. It has agents, or they were called chat modes previously, instruction files, prompts, skills, a whole bunch of stuff. And so it's a good kind of bucket to go to. Actually, I might just quickly bring it up. Sorry, I should have brought it up before. I'll go back to someone just put it on the screen. Thank you, whoever shared it, but I'll bring it up anyway. And yeah, this one. So this is Awesome Copilot, and I'll zoom in because you won't be able to see that. But this is the repository, github.com/GitHub Awesome Copilot. It's been shared, but it has a collection of like prompts and instructions and things you can leverage for GitHub Copilot. There is also an MCP server as well, which you can use, which I'll demonstrate and see if it's working today, and we'll see how we go. But essentially, this is where I went to say, all right, I don't want to create anything from scratch. I wanted a plan, and then I wanted to essentially go from there. So this is where I started. So if you haven't been here before, it's a real great repository to use. I'm a big advocate for it, and it's aptly named. It's pretty awesome. So check that out if you haven't already. It's really cool. So just go back to my browser. Sorry for all this switching around. Okay, so, well, now I know that I've got a repository of things that I can leverage. So I need to create a plan. So I'm going to try the MCP server. We'll see how we go. So I have it installed already. So if I go Awesome Copilot, I need an implementation plan. I'll do something vague just to see what it returned back. Now, let's see if it's working. But essentially, I want to come up with a plan to start with something. Cool. So I'm going to allow it, saying, hey, it's trying to get out. So I'm just going to say, for the purposes of this demo, I'm just going to allow in this session. Obviously, just when you're working with MCPs, be secure, make sure you trust it, make sure you see where it's going, and only allow the prompts you want to allow and external calls. But you can see here what it's going to do. It's going to go back. Oh, yep, I'll just allow this as well. It's going to say, yep, just allow in the session. I know it's safe because I've used it before. But what it's going to do, it's going to go and essentially scan every area of the repository. So I'm going to allow all these things through. There's probably another one that's going to pop up. But essentially, it's going to go through and check whatever if it can find anything related to an implementation plan, and ideally return things I can use inside my Copilot. So let's have a look. It's having a think. So it may have picked up one that I already had in there. So let's see what it's scanning my repository now as well. So let's see what it comes back with. So yeah, like this is a great way to bring in things from Awesome Copilot into your code editor, into your repositories and things like that if you haven't used them before. And it's a great way to get them in. So it looks like it's trying to create a new plan already for me. Not what I wanted to demonstrate, but that's okay. We'll just give it one more second. If not, I could bring up the plan while it's thinking of what it's doing. So essentially, this is the process I followed. I went through there. I got essentially what I'll bring up is wrong one. This one. It was this one. It got the implementation plan. Agent is now called, or previously called chat mode. But essentially, this is the chat mode of agent I got from Awesome Copilot repository and just put it in there. And you can see here, I might just stop this because it's not doing what I wanted to do. But essentially what it's doing here is essentially I just copied and pasted, didn't change it as is. And as you can see here, it's a very well structured agent, which tells it exactly about how it can create plans and where it should save it and what it should be doing. It's a great way to kind of change the personality of GitHub Copilot. So when you create a plan, it will actually follow this for you. So what you do is you put it in, I don't have it in here, but an agents folder, and essentially you can put it in there. So once you got it in your .github directory under agents, you should be able to choose it from here. So you can see now it's going to use that agent for all my prompts going forward. And what I'll do is I'll just clear the screen so it's easier to see. So essentially, now that I've got an agent going forward, I've got something to help me create a plan. Because if I create it from scratch, it wouldn't be as comprehensive or as detailed or anything as I wanted. So, like fantastic, I've got a way forward. I'm using AI. So all I did was quite simply was I put in a simple prompt saying, create a plan to implement logging for my application. It is a static web app and must use Microsoft best practices. So something like that. You know, you can be, I'm being vague on purpose so you can see it, but you know, you can be as detailed as you like. But I'm like, well, I know there's prompts I can use as well. So what I actually did is actually grab the prompt from Awesome Copilot as well. Save it here. So there's actually a create implementation prompt as well. So if you bring that in, you can see it live. I'll just bring that in as well. And it helps create a bit of structure for GitHub Copilot. So what we can do, I don't know how quick it is actually, and it's pretty good. Yep. So now I'm using that prompt. Let me close all this. It's a bit messy. So I've used that prompt as well as the agent as well, and that is essentially how I ran it. So using the agent to kind of tailor GitHub Copilot in the direction I want it to go, and also use the structured prompt to return things in a bit of structure for me as well. And essentially I went away and I went, yep, go for it. So we'll see what it comes back with live. Like I said, I do have already implemented some of this change already for the demonstration, but let's see how it goes. So it's probably going to pick up that I already have some form of logging because it created the login LX workspace and app insights and things like that. But essentially it should come back with hopefully something a bit more structured. And if it doesn't, I will show you what the output actually was. Okay, so we're going to allow, it's going to create a new item for me. So it's going to create a new markdown file where it needs to. So I'm like, yes, that's fine. Under the plan directory. I already have one there. So, yep, so you can, that's just popped in. Fantastic. So now it's going to go and write the plan according to my prompt and my structure as well. Now, what I'm expecting is for it to come back with a structured plan for me to follow going forward. So let me just open that up. So at the moment, it's still empty, so it's still thinking and doing its thing. So we just give that a minute or so to see what it actually comes back with. So if you can see it, hopefully we can see it live. If not, I'll show you what the actual plan I actually came back with when I was actually running this. Okay, that's thinking a little bit. So what I'll do is I'll switch to the actual plan while that's thinking. So this is what I came back with when I ran it. Let me scroll to the very top. So when I ran that prompt, this is what I came back with. As you can see, it's quite, I'll just scroll that and I'll see if we can see it a bit better. Yeah, so that's probably a bit easier to read. This is what I came back with. So this is the plan it came back with. So you can see here, it gives a bit of a description. It loaded all the requirements and constraints. So you can see here, all that sort of stuff was required, you know, implement application insights, you know, monitor behavior, track metrics, real-time performance, the health, et cetera, et cetera. Security requirements, technical constraints, guidelines and best practices. So you can see it's actually quite detailed, and there's no way I would have done that. Well, if I had to do something like this, it would take me a lot longer to do, and I just didn't have the capacity to write a detailed plan like this myself. So you can see here, I wrote the implementation steps in different phases. So it said, look, phase 1, it's going to set up the infrastructure, you know, and it broke down into different tasks for me. So let's say, you know, task 1, create the Login Analytics workspace. Task 2, create Azure App Insights, so on and so forth. And then phase 2 is the integration of App Insights and the steps that follow as part of that. And then, you know, phase 3 is, you know, the custom React monitor hooks, so on and so forth. So it's kind of broken down in different phases, as you can see. And if I scroll down, I can't remember how much phases there are, 10, 11, documentation. So there was 12 phases, including documentation and testing. And then I also noted some alternative approaches, any dependencies that it caught, all the new files it's actually going to create, all the files it's going to monitor. So you can see it's really quite comprehensive and detailed. So that's pretty good for just writing a simple prompt saying, help me come up with a plan. So that was great. So I now have a plan. So what I needed to do going forward was, now that I've got a plan, is, well, what's next, right? I've got a plan. It's great. I didn't have to spend a lot of time myself working on the plan. I got AI to help me with the awesome Copilot leading the way and leading Copilot in the right direction. So that's fantastic. So now it's more around, I think it's finally woken up and it's doing some stuff. Yeah, okay. So you can see here, it's created the plan now. So, yep, so Copilot has woken up. So this is the plan that came back live. We should hopefully get something similar. I'm not going to get the exact same things. I had used a different prompt. So if I open this up, the structure should be the same. So you can see here, oh, sorry, I opened up the same one again. It was this one. Yeah, so you can see here. So this is the one we just went through live today. It's done 10 phases, 52 tasks from my one simple prompt, right? Now, obviously, the more detailed and better, I was vague by design for today's demonstration, but the more detailed in your prompt, you know, better results and more accurate your results and plan will be. But you can see even from a vague prompt, how you can use GitHub Copilot to help you generate a plan quite quickly with the help of an awesome Copilot leading the way. So you can see here, it's got functional requirements, same sort of thing, all sorts of requirements detailed, and it's got the implementation steps in different phases, and then it's broken it down into tasks as well. So it's the same structure, same amount of detail, nothing's lacking from a comprehensive and detailed perspective. Now, obviously, you can come in here and tweak it and change things. This is just a first cut, but for a first cut, I found it really good, really helpful. So you saw that live now that I created that plan. You can see here I didn't actually have to go and tailor anything, whole bunch of stuff. So it's got even related articles here, lots of different cool things for you to kind of review. And obviously, you can make sure you review it in your plan, and the things in your plan are exactly what you want to execute. Make sure, it's going to create the new files and the new locations and all sorts of stuff. So we have a plan, and I just realized the time. So I'll wrap it up pretty quickly because I realized I talked too much. So I have a plan. So my next step was, well, I have a plan. That's great. Well, what's my next steps? So I needed to create, essentially, I need a backlog of items to pick at based on my plan. So naturally, I went back to Awesome Copilot. Let me just close this off my screen. And as you would imagine, there was a prompt where you can create, not this one. There was a prompt where you can create GitHub issues from an implementation plan. Perfect. That's exactly what I wanted to do. So I just saved that prompt. It's already there. Here. And then that's exactly what I did. I said, go create an implementation, create GitHub issues from an implementation plan. And what it did is it uses the GitHub MCP server, and it creates a backlog of items. So, and if I switch here to GitHub, you see in here, what it did is it created all these issues for me to kind of work on. So it grabbed everything from my plan, and it created a backlog for me. So I'm like, perfect. I now have a plan, and I have a backlog to work at. But what it didn't do is it didn't help me with my initial problem was I don't have capacity to work on this. So all I did is just generated more work for myself, which is not what I intended. So I have a plan here, and I have a bunch of backlog, but how do I solve this problem where I don't have to spend time or dedicate a lot of time to this because I have to context switch. I've got lots of things happening in my day to day. And AI tools are out there, but there has to be a smarter way to work on these things. So again, in comes GitHub Copilot to actually work on these things. You can actually assign now, so if I pick up one of these issues, you can actually assign this to Copilot itself for it to work on. So of course we can. So that is essentially how we leverage Agentic DevOps, end to end. Now I'll switch to my web browser and I'll show you there is a closed issue, which I'll show you that I assigned to Copilot, and it actually implemented it itself with some guidance as well. So I'll just switch to that because I do have to wrap up. So just bear with me. Last time I'll be switching, I promise. So share screen. Okay, so this is my repository. This is public, so like I said, I shared earlier. Now, if I go back, just so you're seeing the same thing, this is what I showed in my VS Code earlier. The issues that it created, you can see is one closed. So I'm just going to open that one up. This is the one that I assigned to GitHub Copilot, as you can see here. So you can just pick it up and just type Copilot in and assign it. And once you do that, away it goes, and it will start working on it. So you can see here, it created a pull request. And that's what it does when you assign to it. And when you first create it, when it first creates a pull request, it'll prefix it with work in progress, WIP. And then it'll tell you exactly what it's going to do in that pull request. You can see here, away it went. So if I just scroll down, it's very detailed. It's picked up things from the plan itself. So it knows exactly what to work on. It has all the information, all that sort of stuff, which is really awesome. So then you can see here, the great thing about this is I can just write some comments, review it, test it, because I had that kind of capacity, but I didn't have the capacity to kind of do the development myself. So what I did was I just put comments in saying, leading it in the right direction. So you can see here, I put a comment saying, hey, Copilot, it was using Azure verified modules, but they weren't using the latest version. So I said, update it to the latest versions. So then it starts to work on it. And you can actually click this view session button if you want to see it live, or you can, like in my case, I went back to my day-to-day, right? Then it comes back and it says, cool, I've come back and I've made those changes. Here's what I did. I updated Log Analytics Workspace from 091 to 012, you know, et cetera, et cetera. Then I said, look, that's all cool, but you didn't incorporate the environment name into the web app name, so you need to go ahead and do that. Then it came back saying, yep, I did that now. Your environment name is now going to call Imperial Supply Hub, Static Web App, Dev for Dev Environment. Perfect. And then I realized, well, hang on, you've got a bunch of errors in my bicep file. I don't like errors, and I need you to enable diagnostic logging. So I went ahead and did that as well. If GitHub Copilot tries to get to an external source and it can't, you'll get this message saying, hey, I'm trying to get to this source, but I'm blocked. You'll need to open up the firewall rules so I can get there. So it doesn't have carte blanche access to the internet. You'll have to go and allow a Copilot to get to certain sources. So just be aware of that. And you can see I've gone back and forth, right? I'm not going to go through every comment I went through and back and forth, but you kind of get the idea, right? So I was going, the idea is I had capacity to kind of create these comments, go back to my day-to-day, come back, see what it did, and actually work on other things that I had to prioritize in my day-to-day. So that's really the power of Agentic DevOps. You can use all these tools from planning to creating backlogs to leveraging Copilot itself to do development, and you're really just steering it in the right direction. That's really the power of Agentic DevOps. And when I was happy with it, then I just merged the pull request and away I went. And that's how I delivered the major enhancement that's essentially the process I followed end to end on how I delivered the major enhancement using Agentic DevOps for the internal IP, and obviously, as you saw it here live today, on this, fictitious Star Wars Imperial Supply Hub app I made as well. Process is the same. So if you haven't tried any of those things, awesome Copilot, great collection, MCP. As you saw live, it created the plan for me after a simple prompt. Then you can use that same process to create the GitHub issues and create your backlog. And then you can assign Copilot to work on those backlog items. And you can kind of just review it and steer it in the right direction. That is it from me. Any questions? Anyone have any questions?
Nope, no question. Yes, we're just waiting.
All right, I'll wrap up. I'm a few minutes over. Sandhosh is used to it because he's used to me talking for days. So, like I said, if anyone has any questions, feel free to just shoot it through to me on LinkedIn or contact me. More than happy to answer any questions.
Okay. Thank you, AJ.
Thanks, man. Appreciate it.
No, thanks.
Thanks, AJ.
So the next we have Santosh. He's going to speak telling us about Azure Virtual Network Manager.
Hi, Nick. Just want to make sure you're able to see my screen.
Yeah, I can see your screen, but I can see the island, your wallpaper. Are you using on the screen?
Yeah, probably I need to change share screen. Okay.
I would share the window instead of the screen. Actually, the desktop.
Yeah.
Okay.
You're good?
Yeah, good. The floor is all yours.
Good. Yep. Thank you. Hi, everyone. Good morning, good evening, wherever you're located. It's good morning from Melbourne. So Nice to meet you, everyone. Thanks, Nick, for organizing and getting my session up and running. Thanks, AJ, again. I'm Santosh. My full name is Santosh Kumar Anandakrishnan, based out in Melbourne, Azure MEP. This is my third year. I think the last year I got dual MEP with networking and the security in Azure. And my today's session is about the use cases to use of Azure Virtual Network Manager in the landing zones. Before we deep dive in, just a quick intro about me. As I mentioned, I'm an Azure MEP, currently based out in Melbourne, calling it a home probably for 13 years now. Basically from India. I hold Azure MEP for dual category networking and security. Infrastructure, mainly with public and hybrid cloud. Anything you want to do with infra, networking, security is my core skill set. I'm not a developer like AJ. And last thing about my personal side is I love cricket. So you can find me on cricket ground playing, or I started doing umpiring now, professional umpiring. And the second thing is I can do anything outside of the thing. My work is the blogging. Feel free to reach out to my website to get my blogging and insights, what I do with that. Let's deep dive in. Today's session is about Azure Virtual Network Manager. We have a couple of stages of agenda. Like, I want to give you background why Azure Virtual Network Manager, what is its overview, what is its core functions, and out of the core functions, I want to deep dive into security rules, connectivity, the topology, the IPAM and UDR, how does it works. I want to give you a high-level view on it and what is the difference it brings in, and a small demo about it and how do we use it in the real-time experience. Okay, before I get into Azure Network Virtual Manager, I want to give you why it is required. If you're in charge of creating and maintaining Azure virtual networks in your enterprise landscape or in the Azure environment, you might see the slightly complex or environment where you can have the network security groups, VMs, VNets spread across the region, subscriptions. You might see some questions like, how do I enforce security across a centralized from your single dashboard or a window where you want to do it across your tenancy level or the management group level. As an administrator of Azure networking, if I manage NSG, I need to enforce the NSG across your landscape. I want to block a single specific rule across your subscription, irrespective. As a security person, a security administrator, I want to block, for example, RGP. I don't want to allow accessing VMs directly from public internet. I want you to block it only with the Azure Bastion. You can do that. And how do we do that? And how do I give access to an HTTPS application irrespective if someone blocks it? Say, for example, if someone who has an access to an Azure subscription, they can just enable by knowingly or unknowingly an RDP traffic. They can just enable high-risk traffic on the port. So you want to enforce the standards that sets across your landing zone. How can I protect my VMs and VNet at a scale when we identify a new high-risk traffic? You want to block a specific port across your subscription, the landing zones, wherever you have it within your tenant. And do I need to really configure the NSG one by one to block this traffic? So all these things provides an opportunity to have a single dashboard to view all those things. Whatever is spoken in the last slide, it's just been taken over by Azure Virtual Network Manager. It significantly reduces your operational overhead with AVNM, a centralized management service for your Azure Virtual Network resources. Easy to manage your network infrastructure with the scaling of whatever you want to do with connectivity, like topology, like hub and spoke. You want to do a mesh, you can do a security rule, blocking a highly risk traffic. You can have complex network topologies. You want to do a mesh, you want to do a hub and spoke, you can do all these things. And you can do across your cross-tenant as well and across your Azure environment as a landscape. What does it provide? It provides a centralized solution to create and manage your complex network topologies and network security rules. It can apply rules at organization level, and it can enforce at the scale, enforcement across your landscape. A single deployment configuration across a specific region, and you can do cross-region as well. Automated management of your virtual network topology like hub and spoke. Like as a Azure administrator, if you're deploying a new resource coming into your landscape, you want to make sure that spoke virtual network has been peered into your hub by automatic. You don't need to do anything. Even if you forgot to peering it as part of someone's deployment, this specific tag or something you go on to specify that makes sure that Spoke virtual network has been peered into the hub. By that way, you're just connecting all your virtual networks into a single standard way you want to carry forward in your environment. So what are the functions it brings in? It just gives you security like admin rules. I'll deep dive into what is admin rule. It is not exactly an NSG. You have a higher priority than the NSG, so that the AVNM security admin rule will take precedence over any rule. So you can apply to the existing networks, you can apply to new networks, you can make sure the new networks are part of your hub and spoke or network topology, whatever you want to call it. You can block the traffic based on the requirement, what you wanted across your landscape. And you can just have a specific topology to be created, and that can be performed across your landscape as well. So these are the things which brings into the via Azure Virtual Network Manager, and this helps us to form a unified, scalable virtual network management across your landscape in Azure environment. We spoke about the complex, what it brings now with this. Let's see how do we create it actually. Azure Virtual Network Manager requires 4 different steps. The first thing is you have to create Azure Virtual Network Manager, the basic configuration. The second thing is you have to create network groups. Network groups is nothing but a logical space where you can combine or you can pool of all your virtual network which want to have the same set of configuration. It can be network configuration, it can be the security rule which blocks the traffic, it can be the UDR configuration like user-defined route configuration. So you want to group all the virtual networks into placing them in one single logical network groups that manages the network resources. The third thing is you have to create the required configurations, like I mentioned, security, the topology, and the UDR, so that which can have the same set of rules applied to that specific network groups, which we created in step 2. And the final step is you have to deploy that configurations. Whatever we created in the network group and the configuration, you have to deploy that configuration to a specific network group so that it applies and make sure your enforcement is active and take place it. So we saw how do we create it. What are the functions of Azure Virtual Network Manager can provide you as instead? As first thing is network topology. As the name indicates, it provides you configuration of the layout of network connections and its topology. Currently, it provides hub and spoke and the mesh topology and direct connectivity. The second thing is security rule. Security rule is nothing but it's a kind of a network. It's not exactly an NSG. It will be precedence on NSG. What it provides is, as an administrator of AVNM, you manage the entire landscape of Azure Network Virtual Networks. So you have an ability to block and deny and make sure you can allow a specific rule irrespective of NSG. Say, for example, if someone is blocked HTTPS for a specific application and you want to make sure the HTTPS has been accessible from your internet or internet network, then you can just go and enable on top of that actually. And the third thing is user-defined route configuration, which provides the routing table to be set across your network virtual network manager, across your networks, and make sure it has been unified and consistent across the landscape. And the last one is best part of this, I like it, is IP address management. As someone coming from infrastructure, you know how to manage and allocating IP address, but as an IPAM provides us as a pooling level of information, which provides you a specific IP pool for your virtual network creations. We'll deep dive into this in coming slides now. The first thing is network topology. What does it provide? After you deploy virtual network instances, you create network group, which serves as a logical container for networking resources to apply configuration scale. It is similar to a resource group, like you just manage all your resources into a resource group. Similar to that, you manage all the networks into network group. You can manually select the individual virtual networks to be part of that group, or you can create a static membership, which can use Azure policy to define the condition with a specific tag or specific information or specific region you want to bring it up into a dynamic group that works. As I mentioned earlier, AVNM works with the same region or the cross region as well for a peering. So the static groups is by providing a default region, and you can just take it up by default on manual addition. The dynamic group, you can use tags, or you can do an advanced editor with the JSON to provide a specific tags or specific set of information provided. Based on that, it will create a network group that picks up all the networks. It can be existing or it can be in the future as well. So that way it is dynamic. The configuration levels, as I said, 4 different configurations you can use. 3 different configurations. Fourth one is IPAM. The first one is network connectivity configuration. The connectivity configuration allows you to create different topology, the mesh network, hub and spoke with the direct connectivity. As a mesh topology, in the mesh network, all the virtual networks within the network group, which you created a logical container, which provides interconnected, enabling the bidirectional traffic between them. This topology helps the spoke networks communicate directly to other with reducing the latency, and which provides secure. It provides a reduced latency by bypassing the hub. There is no hub here; it just connects across each other spoke networks. The security can be managed through NSGs, and traffic can be monitored using network flow logs. By default, what we do as it is. By default, the mesh is regional, but the global mesh can be linking virtual network across all other regions as well. Second option is hub and spoke. That's a traditional method. What you do as a hub, which one of the virtual network act as a hub. A hub and spoke topology is a network structure. It creates a central virtual network, which is called as a hub, and the spokes are paired to that. And setuping allows the resource sharing while isolating the spoke networks. There is no interconnectivity between the spoke. The spoke connectivity between via hub and spoke is via the central hub. You have to make sure the traffic is diverted by a hub and make sure that's been passed to the next spoke virtual network. The key features including enabling direct connectivity between the spoke, typically limited to those within the regions level. And the global meshes can be activated, and gateway transit can be used in hub and spoke. And the last option is the direct connectivity, which establishes an overlay group, allowing the communications only among the VNets within the same group. For instance, if you enable direct connectivity for a production network group, but not for the test group, only VNets in the production group can connect each other, but not with the test or the non-prod VNets. That's why it just provides you direct access to a specific set of virtual network groups. The second thing is security admin rule. This is security admission configuration, which includes the network traffic rules are grouped into rule collection similar to the NSGs. It just gets everything into a rule collection and applied to the one or more network traffic groups. Say, for example, you have a specific network group for prod and test. You want to make sure the rules are applied for the prod and test or being similar. You want to make sure that the testing environment is same as equal to production. You can just apply that rule. These security admin rules are evaluated before NSG getting processed. So they have a higher priority than the NSG. It is not exactly an NSG. It has a higher priority than NSG. It's kind of something similar, but not exactly in the same way of evaluation. If you have an NSG and if you have security admin rule, the evaluation process is, first thing is security admin rule in AVNM. The next thing it goes to NSG. And this allows an AVNM configuration to be defined at a enterprise-wide level at the management group or something on the AVNM scope level to restrict and allow traffic, while still allowing subordinate teams to manage their own NSG based on their application of the resources as part of their landing zones. The security admin rules does not change the NSA. Instead, they defined independently, and security admin rule won't change anything on NSG. You have to be very keen on it. Actually, there is no change happening as far as you do in security admin rule. It just has a precedence. It doesn't change anything as it is in NSG. The security admin rules are exactly like what you would expect from something like NSG or firewall. You select the priority, the direction, inbound and outbound, allow or deny. There is one change here is, other than allow and deny, there is something called always allow. The traffic that means always allow rule will be allowed without getting evaluated by NSG rules, or the lower priority of the rules it's called. So let's see how that works here. As I mentioned, security admin rules is not exact as NSG, but how does it work is security admin rules is enforces security policies across the virtual networks in your Azure enterprise organization. Security admin rules take precedence over the rules that NSG defines. Security admin rules applied at first in traffic analysis as shown in the diagram. So what happens is when you see the traffic comes in, the actions performed here are allow, deny, and always allow. What happens in allow scenario is it hits the traffic, AVNM checks the traffic state. It's been defined allow in AVNM security configuration. So the traffic passes to the NSG rule in the back to make sure the resource has that NSG rule to allow it. If you have allow, it just takes that to a target subnet. If the NSG rule has a deny, then the traffic denied at the NSG level. The second set now. If the security admin rule has a deny by default, it just blocks there. The traffic won't pass to NSG or the resources backend at all. It just stops in AVNM. So that way it helps you to prevent any traffic you don't want to allow. It just stops there. Immediate traffic blocks. And the last one is always allow. What happens is here is the immediate traffic forwarding directly to the target state with irrespective of what the NSG rule has been defined for the specific resource. Say, for example, you want to allow a HTTPS internet traffic to an application by just making sure always allow. So that any traffic hits on 443, it just goes back to target subnet or the target resource in the backend via AVNM, irrespective of what NSG rule has been defined by the administrator of that specific subscription. So that way, it just provides you a direct access control over for you. On the deny rule, what we can do is, as mentioned earlier, you can deny your RDP access for any of the virtual machines directly from internet. You just want to enforce all the traffic of RDPs via only your Azure Bastion, so that you can define, that access is enabled and deny access on anything on the internet directly coming from a public IP address. So that's why it helps to have that full security control irrespective of that autonomy is being provided for a specific subscription level access to a application team or whoever manages that specific subscription. So that's the difference between security admin rule versus NSG. It has three type of rule, as mentioned. Allow, it's always non-terminating. It just passes the information back to the NSG. Always allow, it doesn't just make sure the traffic is passed towards the target state. And deny is just terminating at static level. That's it. To give you more understanding about how this rule and scope things works, right? I just want to focus on this slide. The administrator can create security admin rule. Okay, let's say you're a company administrator. You want to make sure that traffic enforces a rule to block inbound SSH traffic across your organization in Azure. Managing NSG leads to high overhead, allowing the product team to manage their NSG could expose security risk. The solution is to use both security admin rule and NSG. So you have precedence over your NSG just being created by the specific administrator of that subscription. So as a AVNM administrator or the security admin across your agents, across your organization, you have the control. You create an AVNM and your scope for the AVNM is on the top level of the management. And you just create that network group. You have to application network group and you have an all network group. So all network group has all the 5 virtual networks and application network group has only VNet 4 and 5. The administrator can create security admin rule to block inbound SSH traffic for all the virtual networks while allowing exception for specific networks requiring for SSH access. This approach maintains a security while accommodating exception as required using the priority order. So what happens here is there will be 2 different network groups. First network group is all network group like VNets from 1 to 5 and application network group is only for VNet 4 and 5. If you want to allow a SSH exactly for that specific testing group or you call it as exception group, that application network group, you just allow that order of 10, make that as a first 10. Number 10 is the lowest priority, that takes a precedence. So you allow inbound only to that specific virtual network group. The order 100, which is being the second highest priority, which will deny all the inbound traffic for the rest of the group. So in this way, you provide an access to maintain a security exception for a specific set of time, or you want to allow it for a couple of days for the testing, then you make sure it's been taken out. So that way, it just provides that flexibility to have that way to enable as the exceptions required. So far we covered 2 configurations. One is network configuration, which has been topology like hub and spoke and mesh and direct connectivity. And the second one is about security configuration, which speaks about security admin rule to block your traffic. The third configuration is user-defined routes management. As an administrator who will be managing via your hub and spoke, you want to make sure the route table is consistent across your Azure landscape, and you want to maintain that across your all infrastructure so that you can keep consistent across. As AVNM requires a managed resource group to store the route table. What happens is, as you create an AVNM, it creates its own specific small resource group in the backend to store all your route table. If an Azure policy enforces a specific tag or properties on the resource group, you have to make that exception to be allowed for this. While you're applying this configuration, what happens is when you have a conflicting route rules exist, a same destination or a different next stops, only one rule will be used. The others will be ignored. The conflicting rules that target the same virtual network or subnet are not supported. If you create a routing rule with the same destination as an existing route, the new rule will be ignored when the route tables or UDR, Azure Virtual Network will create a new managed route table that includes old and route. The other UDRs will be added or affected or deleted when you remove the routing sets. So I'll show you how this works in a real scenario when you go into the demo session. The next configuration is about IP address management. This is one of the key services, and one of my favorite as part of Azure Network Manager is Azure IPAM supports network administrator by ensuring no overlapping IP prefix or automating the assignment of IP addresses to resources while of the subnets creation or the virtual network creation. What you have to do is you have to create an IP address pool, and each of these IP address pool can be allocated against your virtual network creation. While creating a virtual networks, there is an option for you to select from specific IP address pool allocated from the administrator, or you can just select it from a specific region as well. Like you use it for Australia 10.10./32 or 24, and you want to use it something for London for 100 or 100 or 10./28 or something. So you can just segregate that based on the region as well, and that way it helps a non-administrator and someone non from infrastructure no need to worry about IP addressing. It just picks that what is available as per their requirement. Like if they want /24, they just take /24. If they want something /28, they just picks that from the IP address pool specific to the region. So this way it accelerates the deployment to applications or anyone who doesn't want to have an access or doesn't know anything about the background of infrastructure or something. What does IP address provides? It provides an IP address pool. The organizers manages IP address space efficiently. Resource management, you can have static IPR as well, and you can provide the permission management so that you can create, network admins can create pools within the defined address spaces and sizes, allowing for planned and organized IP address usage. The pools can be structured in a hierarchy, enabling the divisions for a larger pool into a smaller subnet or more manageable way. IPAM supports both IPv4 and IPv6, and the specific pools can be assigned to Azure resources like virtual networks, making it easy for tracking the address spaces and visibility wise. And you can just make sure you can see what are the IP addresses being used when, and CIDR is associated resources are deleted. Allocated CIDRs are automatically released back to IPAM, ensuring that efficient utilization of IP space is being across your organization. So we spoke about a lot about the functionals and the configurations, what it has at the stage. Let's see how does it works in a real scenario in a landing zone. AVNM in landing zone, you have to create. First thing is AVNM has to be created. The second thing is the VNet creation, IP address allocation with the IPAM, because the VNet creation can come from the IP address pool, which is being associated with Azure Virtual Network Manager. When creating a new landing zone, you need to perform tasks like creating a new VNet, defining a non-overlapping IP address range, setting up a peering, creating routing, and configuring security rules. All this can be automated with AVNM. AVNM can automate all these tasks. First, you have to ask AVNM to create a new VNet with a non-overlapping IP address, which from the IP pool, which has been part of AVNM. AVNM can also automate, create new work groups, and leverage the concept of dynamic membership as part of network groups so that your topology is consistent across your organization. For example, you can create a tag, VNet associated with a specific application team or spoke topology. AVNM then automatically create that with your network and put them into a network group. And you have a network group which is being used for your creation of the rules and the topology to be maintained. So with this, you can have security admin rule, user-defined, IPAM, network topology configuration. This eliminates the need to have someone to manually set in various components required for landing zone, and everything is handled via AVNM in automated fashion. How does it look in a landing zone? You'll have multiple management groups, you have different network groups. On top of that, AVNM instances, making sure a lot of things required for AVNM can be automated, like topology, peering, IP address, rules of security rules, and user-defined route table. The network groups can be dynamic, and the VNets, which is to be the centralized hub, should not be part of any network group. It should be selected separately. I'll show you the demo session. This is how your AVNM will look like in Azure Cloud. When you have AVNM instances, that should be as part of your the hub virtual network, and all your peering across goes through the AVNM to make sure it's been consistent across your landscape. How do we use AVNM in this case? Common use cases include create standard rules that must be applied and enforced across all existing and virtual networks and newly created virtual networks. That is, from the security side, you have to make sure the traffic is being blocked or enabled, and create security rules that cannot be modified and enforced at the wider organization level for your Azure tenant. Enforce a security protection to prevent users from opening high-risk ports. Create default rules for everyone in the organization so that admins can easily prevent a security threat or misconfiguration in NSG. So all these things comes as part of your security to making sure it's been consistent across your topology or the network landscape within the Azure. Create security boundaries by using security admin rules as an administrator. Let the owners of the virtual networks configure the NSG, and you provide autonomy to the administrator to manage their own NSG. But on top of that, you can create and maintain the security of your configurations required as part of the network traffics to be enabled and then denied. Force allow the traffic from end-to-end critical services so other users cannot accidentally block the necessary traffic, such as monitoring services or like Azure Update Manager requires a specific internet outbound. So all this can be managed, and you just maintain the topology and security of your Azure virtual networks. I think I'll stop there. It's a demo time. Let me bring in my other screen. Okay. So this is my Azure Virtual Network Manager, which I created a couple of minutes ago before my session today. And you can able to see I have some security admin rule created. I have my connectivity configuration created. I have my routing configurations created. And these configurations are active in 2 regions. I have made some 5 deployment. This just gives you the entire information. So I'll show you how do we create an AVNM here in case if you want to start it from first. So let's go in here. Like once you create AVNM, the next thing you have to do is you have to create a group. So then all your network. Hi, Nick.
Have you lost connection? You've lost connection.
Yeah, something is bad. Sorry.
No worries. Just continue. I'll just combine it. I'll just edit it out.
All good.
I'm just putting it in.
So yeah, we're here, right? Yep. Sorry, guys, got some issues. These are the three configurations I have. One is hub and spoke connectivity. The second was a security admin rule. The third one is a routing configuration. What happens here is in the hub and spoke, I have selected my hub virtual network. I have make sure what are the network groups being part of my scope. So that way, the traffic goes across. You can have something like resource visualization, which helps you to visualize your configurations and making network has existing pairing. It recreate yet that can be doable as well. So you see this is being deployed across here, all the regions. And if I go back to my AVNM, I have a security admin rule. What I've tested here is I have created a specific rule to deny an RDP. So any RDP across my network group has been denied from. So security admin rules helps you to keep it more secure in the traffic so that you don't allow any high risk traffic in your organization. Yeah, in the mean, I'll get the IPAM as well because slightly slower in my side. I have some issues now, so sorry for that. Just divide that IP addresses pool and just specifically allocate that for a specific subscription so that you can use it across it. So you don't need to provide any information, just create the IP pool and ask the team to just go and associate that IP address pool against the virtual network. That will pick based on the /22, whatever they want to use it. They'll just go and carve out that IP addresses from the IP addresses pool. Yep, I'll stop here. I think this is what I want to cover up today. Got slightly stuck with my demo, but yeah, I think this is what I want to show you guys a little bit on it.
All right. Apologies, everyone. Santosh has a little.
Yeah, sorry guys.
Demo.
Yeah, my demo was probably I'd say more than halfway, but yeah, I couldn't get exactly what I want to do it. But yeah, I'll post my slides and things up in the LinkedIn. And if you have any questions, anything on this, just hit me up. Yep.
No, it's brilliant.
All good. Thanks, Nick.
Thank you.
Is there any questions I have?
No question at the moment.
Is there any
questions? So if any question, they'll just drop you a message on LinkedIn.
Yep, sure.
Yeah.
Ping me.
Thanks for joining again, Santosh.
No worries. Thanks, guys. Really appreciate it. And sorry for the slight delay in the end.
No worries. So if any question, you can drop Santosh and AJ a message on LinkedIn and with any issue, and then they will just give you a link to their repo or what they've used in demo. So you can just follow along.
Yep.
Okay.
Cool.
So I would say stay tuned for the next episode. I would say next month. The speaker's not been announced yet. So thank you. Bye.
Thanks, Aaron. Chilly.